Okay, okay. Ajay, if they're saying show that, so in a show that question, you have to be very careful, and that's it. Okay, so you have to show the power formula, work done over time, and then you have to show the work done, that is like kg meter square second negative 2, and then just substitute. Okay, so kg meter square second negative 2 divided by s, and then it gives you kg meter square second negative 3. Fine. Okay, so the rate of flow of thermal energy. Okay, and okay. By the way, can anybody tell me what is the rate of flow of thermal energy is? Like the unit? Anybody? Yes.
So power,
Power. Whoa. Why?
so power is energy transferred over time taken.
Okay, good, good, good. So basically, Q over T has a whole thing. You can replace it with kg meter square second negative 3, right? So, but first make C the subject and then replace it, okay? So this is one entity, okay, or this is one unit. And so X over A times T equals to C. Fine. Q over T is basically kg meter square second negative 3, right? And X is supposed to be the thickness of the material. So you can by the way you can write Q over T as like the unit. You can write the unit separately. Sorry, 2 and S negative 3. So yeah, and this is x का unit आ जाएगा thickness है meter, so divided by A is cross sectional area meter square. सही है. And and you have T, which is I think the temperature difference. Okay, so temperature difference and temperature both have the unit in Kelvin. Okay, so one goes with that, one goes with this, and the final unit is kg meter second negative 3 and Kelvin negative 1. Okay, is that clear? kg meter second negative 3 Kelvin negative 1. Okay, fine. That's an easy question. Okay, आ जाओ भाई, read कर लो. Irfan, please read the question.
A coin is made in the shape of a thin cylinder as shown in figure 2.1. Figure 2.2 shows the measurements made in order to determine the density of the material used to make the coin. Calculate the density rho in kg meter minus 3.
Okay, so which formula you use?
Mass by volume.
Okay, and how you find the volume, by the way?
Uh, Diameter into thickness, right?
Yeah, diameter into no.
Oh wait,
Um,
no, no, no. Oh my. Okay, never mind. It's cylinder, right?
yes.
Pi r square h.
Okay, so pi. Okay, so they have given you the diameter. So pi d over 2 whole square times h, which is the thickness. Okay, so volume is equals to pi. Diameter is 222.1 exponent negative 3 divided by 2 and whole square, right? And times it by h, which is 2 exponent negative 3, right? So so this is the volume, okay? And you can substitute the volume into the equation, and the mass is given as 9.6 exponent negative 3 and divide by the value, this value. Yes, how much?
2.4 into 10 to the power minus 6.
The final answer or the value of volume?
Value of volume
Okay, 2.4.
into 10 to the power minus 6.
So yeah. Now for the density.
I'm getting 4,000.
You are getting 4,000. Okay. Irfan, are you getting the same as well?
Just one second.
So let me check the answer then. They are getting this thing. 12513. Yes. अच्छा जी वॉल्यूम चेक कर लो वॉल्यूम में प्रॉब्लम हो सकता है so pi and you have d which is 222.1 exponent negative 3 divided by 2 and then whole square and then times it by 2 exponent negative 3. Okay, so
4,000 the answer?
4,000. No, it's
No,
not the
no.
answer, it's the incorrect one. But
Sir, volume was wrong. It was 7.67 into 10 to the power minus 7.
okay, 7.67 exponent negative 7.
7.
Perfect.
Negative 7.
Now, how much the density? I'm getting 12513, right? So you can write 12500, or you can write okay, or 12513. Just yeah, three as a clear ledger. Okay, 12513. Chalo, okay, let's move on. Irfan, percentage.
Calculate the percentage uncertainty in P in
Okay,
row. Okay.
any idea for that?
You have to make all of them into percentage uncertainty because you can't add them
Okay,
up because they're different units.
good. So how many things do we have to add? The percentage uncertainty of mass plus the percentage of uncertainty of the thickness plus the percentage uncertainty of the volume, right? Sorry,
Yeah,
not the volume, the diameter. So percentage
that.
uncertainty in mass plus percentage uncertainty in thickness plus percentage uncertainty in twice the diameter, right? Because of the power. Okay. So now we have zero point 0.5 divided by 9.6. So zero point 0.5 divided by 9.6 into 100. Okay. Plus x is point zero one divided by 2, 0.01 divided by 2 into 100, right? And then 2 times point 1 into 2 divided by 22. Point 1 divided by 22 x point 1, 22.1, okay, into 100. Yes, how much?
Uh, okay, wait, I'll add everything and tell you once.
Okay.
Sir, don't we square D or not? Oh, we do. Yes,
On.
yes.
We have to times it by 2, no? Why do you square it? Power multiply हो जाती, remember?
Yes, sir.
Okay.
I'm getting 6.60923.
Okay. So you are getting 6.603. So 6.6 just given to SF. 6.6. Okay. Let's just go through. Yes. Correct. Okay. Now, the value of the actual uncertainty. Okay. Just find the percentage, just find the actual uncertainty or absolute uncertainty, rho times 100 is equals to the percentage uncertainty. Okay. So 6.6, okay, divided by 100, okay, into the value of the uncertainty, which is 12513, gives you the delta P, delta rho. How much? Yes. Any idea?
825.858.
825.8. Okay. How to write here?
I guess by 800.
Why not 830? No idea?
No idea.
Okay. Basically, the rule to write the actual uncertainty is you have to always answer it in 1SF. Okay. Fine. And you have to include the same power of 10 which is in the absolute uncertainty to the actual value of the uncertainty to the actual value of the density, right? So how will you write the value of the density if you have the exact value of the density is this much? Okay,
Sir,
so
can you do stand
can you do Abru?
like standard form?
You can do standard form, yes, but a standard form should have the same unit then, okay, same power, basically power of 10, right? So it would be quite difficult over here, maybe, right? Like, you maybe end up getting or messing up the thing. Okay, so don't standardize here. If something is standardized, like if it has a power of 10 or 12, um, then just आप उसको जो है ना वो कर सकते हो, right? Otherwise, if it is in like 100 or 1000, then just rearrange it or just make it how it should be. Okay, so so over here you have a 12510. So it is basically in hundreds, right? So you have to write this value nearest to 100. Okay, which should be 125 and then double zero. Okay, is that clear? Yes, guys.
So it's not 1SF?
Over here,
Yeah.
no, bro, देखो इसमें ना हमारे पास रूल ये होता है क्या आपके पास है. Okay, so this is the absolute uncertainty, right?
Yes.
um Absolute uncertainty. Okay, so to write the absolute uncertainty, the rule is write it in 1SF. Okay, this is the rule. Okay, this is the first thing.
Yes.
Now, when you have done writing it in 1SF, after that, count the power of 10. Okay, clear? And
Okay.
you have to give the same power of 10 in, or you have to include the same power of 10 in the actual value of the quantity, right? You don't have to worry about the SF over here. Okay, so यहाँ पे basically हमें same power of 10 या decimal places को we have to focus, right? Clear? But over here we don't have any decimal places, so we have to go with the same power of 10, right? So the absolute uncertainty is basically in hundreds. Okay, like it is nearest to 100 if we make it, or while we were making it 1SF, so the actual value of the uncertainty should be nearest to 100, right? Clear?
Yes.
So that's it. Clear हो गया everyone?
जी.
Perfect. अच्छा, let me show you the answers, the examiner's key. Mm, 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 mm. Wait. So the examiner's comment on the answer says 21, we are doing 22. Okay. So, okay, the part B was the percentage uncertainty one. The majority of the candidate found this part difficult. A significant proportion of the candidate did not seem to understand the process for calculating the total percentage uncertainty. Common mistakes were to give the fractional uncertainty instead of the percentage uncertainty and not including all the quantities used to calculate the density. Okay, many candidates did not use twice the percentage uncertainty for the diameter or use the same uncertainty in the radius as was given from the diameter. Okay, so you have to twice it because it is raised to the second power. Okay. Now the last part is many candidates found this part difficult. Okay, the majority of the answers gave to two or more significant figure for the uncertainty or the answer for the density that does not have the value of the same decimal places as the uncertainty. Okay, so is that clear? You have to give the same power of, you have to write the absolute uncertainty in 1SF. This is the rule and always a rule. Okay. And once you are done writing it in 1SF, then you have to make sure that your actual value should have the same power of 10 or should have the same decimal places if it has either of the two things. Okay. Fine. Let's move on to. Okay. Let's move on. Okay. Yusuf se करवाते Yusuf जरा read कर लो please. यूसुफ कहाँ हो? आवाज से पढ़ना बेटा. अबे यार उस बेचारे का नेट ही नहीं चल रहा. चलो इमाद से करवा लेते हैं. इमाद प्लीज रीड द क्वेश्चन.
State Newton's first law of motion.
Okay. How will you state?
Sir, when an object remains in rest or moves with constant velocity until a resultant force is acted upon it or something.
Okay, good one. अच्छा anybody else कोई और बता सकता है? सबसे पूछते हैं. यूसुफ बता सकते हो न्यूटन फर्स्ट लॉ की डेफिनेशन?
Okay. An object remains in constant motion or remains stationary until a resultant force acts upon it.
Okay. And Rayan, what about you? Any idea? Any definition?
Sir, the object remains in motion or rest until force acts upon it. Resultant force.
Okay. Okay. And Irfan, what about you?
An object remains at rest or moves with a constant velocity unless it's acted upon by an external force.
Good. Okay. So basically, all have the same understanding, but two of you get marked and two of you won't. Okay, right? So Rayan and Yusuf, your definitions are not correct, right? So you may not get marked for your definitions. मैं शो करता हूँ कैसे. सबसे पहले मैं लिख लेता हूँ. Say a body continue its state of rest or motion with constant velocity, okay, until an external force is acted upon it. Okay, guys, Newton first law is related with the no resultant force, right? So if you're saying rest, okay, you are mentioning that you don't have any resultant force, but as far as the motion is concerned, so you have to mention that only the motion with a constant velocity will indicate or can indicate that you have no resultant force. But if you just write the motion, so you won't. Okay, the motion can either be the motion with a constant velocity or motion without the constant velocity, right? So you are not specifying. So you may lose the mark for this thing. Okay, okay, clear, Irfan and no, Rayan and
Yes.
Yusuf. Okay.
Yes, sir.
So this is very important. Okay, let me show you the examiner report. And by the way, guys, please be very careful and very precise while writing the definition and laws. Okay, look, many candidates were imprecise in this definition. Majority omitted constant speed in a straight line. Okay, so if you write constant speed in a straight line, or if you write the constant velocity contain the magnitude of the velocity and the direction of the velocity. And since you're adding the word constant, so this means the magnitude is not changing as well as the direction is also not changing, right? So either to write that or just write constant speed in a straight line, okay, which has the equivalent word constant velocity, right? Or the resultant force, okay. So you have to be very careful in that, right? Otherwise, it's just 1 mark or 2 mark, but you may end up losing that. You're losing them, okay? Can you rest or constant uniform velocity unless acted upon by the external force, okay? Fine. Okay, let's move on.
The angle of the slope to the horizontal is 20 degrees and the box has a mass of 65 kilograms. The total resistive force R acting on the box is constant as it slides down the slope. State the names and the directions of the other two forces acting on the box.
Mm-hmm.
Sir, one is the contact force, which is upwards or
Okay.
perpendicular to the.
Like this one. Okay. And the other one?
Um, the friction or
Wait.
drag force.
No, come on. It's mentioned.
Um,
The
sir, forward
waiter
force.
plane.
Yeah.
Oh yeah.
Okay, good. The weight. Okay. So we can say the weight acting toward the center of the earth. Sorry, toward the center of the earth. And the okay, the normal or contact force. Be careful. Contact force contact force is always perpendicular to the plane, okay? It's not only upward, okay? Most of the candidate write contact force acting upward. No, it's incorrect, okay? Contact force are always perpendicular to the plane. Oh, okay. So if the plane is like this, so contact force would act like this, okay? So it won't be upward every time, okay? So contact force perpendicular to the plane. Okay, let's move on.
The variation with time t of the velocity v of the box as it moves down the slope is shown in figure 3.2.
Acha, by the way, can you tell me whether we can use the equation of motion or forces or work energy power concept over here? Like so far now, what do you think can we use over
Sir, we
here?
can use.
What?
I mean, we cannot.
You cannot
Sir,
use
cannot
kinematics?
use. No, you can't.
Why?
Sir, because it says the total resistive force is like constant, so it means it's moving with constant velocity.
No, come on, not constant velocity. Okay. I think you're messing up. It's quite easy. Anybody else? Anybody else? किसी और को idea? Yes. Can we use kinematics over here? Or can we use forces over here? Oh, yeah, obviously we can use the forces. But can you use kinematics over here? They're saying the box has
What's
a.
the question?
I'm just no, I'm not relating with the question. I'm just asking. Okay, can we use the kinematics over here in this question if they have asked you something related with it?
I
Yes.
don't think so.
You don't think so? Okay.
Acha.
But I'm
Uh,
not sure of the explanation for that.
okay, no problem. I'll explain. Okay. And यूसुफ तुम्हें क्वेश्चन नहीं समझ में
Speed
नहीं
is
आया?
mg sin theta.
I mean नहीं ना वो तो यूज कर सकते हैं ना दैट इज लाइक फोर्स वाले तो क्वेश्चन है सो वी कैन यूज द फोर्सेस कॉन्सेप्ट राइट बट कैन यू यूज द काइनेमैटिक्स कॉन्सेप्ट ओवर हियर यस मतलब आपको कैसे पता चलेगा कि इसमें वी हैव टू यूज लाइक लेट्स से उसने आपसे कहा है कि भाई एक्सीलरेशन निकाल दो राइट सो हाउ कैन यू से कि भाई वी हैव टू यूज द kinematics to find out the acceleration or we can have or we have to use the forces to find the acceleration.
Sir, we can use
Mm-hmm.
because the graph is like straight line, so the gradient is constant.
गुड वन गुड वन गुड वन ओके फाइन वो तो तुमने देख लिया तो तुमने जो है ना चीटिंग कर ली है ओके फाइन but
Sir, mass is also given.
mass is also given okay so the mass the okay so the mentioning of the mass shows that you cannot use kinematics by the way but since the resistive forces are constant okay so it produces a constant acceleration or deceleration right so you can use kinematics by the way okay. So, but if the resistive forces may vary, so then you cannot use either kinematics or forces. You have to use then work energy power. Okay, clear?
Sir, but if the resistive forces are constant, it will move with constant velocity, right?
No, come on. It the resistive for okay. Basically वो एक एक concept है कि if like the forward force is there, okay, and you're moving and the backward force is increasing, and the forward force and the backward force become equal and the object start moving with a constant velocity, okay. So that is the case of the terminal velocity, right? If your object is not on the terminal velocity and if the resistive forces are also there, okay, but there is, okay, by the way, the concept of the resistive force is that it they increases with the increase in the distance, with the increase in the velocity, right? So over here, if we consider that that it is not moving with a constant velocity, because to reach the constant velocity you require time, okay, you require time for that to become in that state of terminal velocity, right? But maybe उससे पहले वाला केस है अगर, right, कि जिसमें आपके पास resultant force is there, okay, and that producing the acceleration, right? So यहाँ पे जो है, यहाँ पे over here we can use kinematics because the resistive forces are constant, okay, and that causes the resultant force or the acceleration to be constant, okay, and which provide the change in velocity, right? So we can use kinematics over here if we want to, okay, but khair, it's fine. So okay, by the way, the graph is given. Imad, can you tell me the gradient of the graph and the area under the graph क्या बताएगा?
Sir, gradient will give you acceleration and area will give you the displacement.
Okay, good, okay. Now let's move on.
Use data from figure 3.2 to show the acceleration of the box is 2.6
Okay, what you
meters
do?
per second. So take 2 points on the line and find gradient.
Okay, but they're saying show that, okay.
So,
So you
so
have
why 2
to
minus
like you have to write as well, okay. You have to explain that gradient is equal to the acceleration, okay, and then start your working. If you directly start your working, then maybe you won't get mark, okay. I'll show you the mark examiner report. So now, if you wrote them down, so you can pick one point right here, which is 0, comma, acha ji, so point 0.8, 0.8, okay, and let's say the last one, which is 2, comma, 6, okay. So 6 minus point 0.8, 6 minus 0.8 divided by 2 minus 0, okay. So 5.2 divided by 2,
So
2.6.
we get 2.6.
2.6. Okay, perfect. Okay, let me show you the examiner report because the answer is correct, right? So, अच्छा, by the way, look, the forces wala part, जिसमें we were mentioning the weight and the normal reaction force. Many candidates were gave imprecise direction for the two forces or no direction at all. The normal force upward and the weight downward were considered to be given with the insufficient detail, okay. मैंने तुम्हें बताया था कि upward और downward मत कह देना, you have to give the exact detail, okay, like it is always perpendicular to the plane or vertical to the plane, um, the normal force, okay, and the weight will always be toward the center of the earth, okay. So unclear whether up and down refer to the slope or the vertical, okay. So if you are writing the up and down or vertically upward or downward, so you also have to make the reference whether you consider ground as your reference or you consider the inclined plane as your reference, okay. So that's what necessary. Okay, so the correct derivation was given by the majority of the very few candidate misread the graph axis. Okay, they're not mentioning anything, any such thing. But if we have, okay, look. So either you write acceleration is equals to gradient, or you can write the formula. You'll get the mark. Okay, but if you don't write any of the thing and just go on directly substituting the value, then you may get one mark only. Right? Fine. Okay, let's move on. Calculate the resultant force. What to do?
So use force equals mass times acceleration.
Good. And that is the resultant force. We have the mass given as how much? 65 kgs. Okay. So 65 kgs into 2.6.
So you get 169.
Okay. 170 ले लेते. Good. आ जाओ.
Determine the resistive force R on the box. So use the mg sin theta as the forward force, and
Okay.
then the resistive force is equals to 170. Then you can just subtract them.
Okay, fine. Yeah, ये डब्बा मुझसे सही नहीं बन रहा है. Okay. So basically you have the forward force as mg sine theta. You have the backward force as resistance only or friction, right? And so
तो फॉरवर्ड फोर्स कॉस नीचे वाला एमजी नहीं होता?
नीचे वाले साइन होते हैं ना बच्चे, अगर
तो
आप याद
एमजी
करो.
साइन थीटा नहीं होता?
देखो ना, ये आपके पास अगर कंपोनेंट बनाओगे, सो ये
जी।
आपके पास होता है W cos थीटा, राइट. एंड ये आपके पास होता है W sin थीटा. ओके.
ओ ओके।
क्योंकि एंगल यहाँ पे होता है ना, एंगल यहाँ पे होता है, इस वजह से हम ऐसा कहते हैं. ओके. सही हो गया. सो दिस इज W और ये थीटा है. सही है. सो और mg cos theta is basically balanced by the normal reaction force. So the resultant force in the vertical plane or in the vertical direction to the plane is zero, right? So only the forces that are unbalanced are on the horizontal plane. Minus friction force equals to resultant force, which is 170. Okay. So mg 65 into 99.81 into sine 40. I think the angle was 40. 20. Okay. 20 minus 170 gave you the F. How much?
Sir, 48.
Okay. 48.
Sir, point one also.
Okay. 48 one, but okay, it will be accepted as 48. 49 आ रहा है इनका. Okay,
So I
इन्होंने
didn't
one,
round.
the rounding was required.
Sir, on the mg sin theta, I didn't. I just used answer minus 170 and I got 48.
Okay, fine. So answer was 170 though, or 169. Fine, सही होगा सर. चलो. Okay, आ जाओ भाई. यूसुफ जरा रीड कर लोगे प्लीज.
Explain what is meant by gravitational potential energy and kinetic energy. Gravitational potential energy is due to the object's
Position.
what's the word? Position in a gravitational field
Okay, सही हो गया. And
because of its
kinetic
height.
energy. Okay.
Kinetic energy is due to the motion of an object.
Okay, सही हो गया. Perfect है. So energy is stored in the object due to its height or position in gravitational field. Okay. And this is energy is stored in the object due to its motion. Perfect. Let's move on.
Okay. The initial kinetic energy. Okay, a ball of mass 400 grams is thrown with an initial velocity of 30 meters per second at an angle of 45 degrees to the horizontal as shown in figure 4.1. Air resistance is negligible. The ball reaches the maximum height of h after a time of 2.16 seconds. Calculate the initial kinetic energy of the ball. So kinetic energy is half mv squared. So half into 0.4 because you make it into kg, then you multiply that by 30 square. So you get 0.5 into 0.4 into 30 square. You get 180.
Okay. I said, don't you get you don't you consider the angles?
Wait,
Yes.
initial integration. I don't think so. Do we?
Any reason? By the way.
Because normally when I see the question, when they give just the initial kinetic energy, I just use that.
अबे come on. कोई अच्छा सा जवाब दो यार. Bro, basically kinetic energy is a scalar quantity, right? So you don't want to have any degrees involved or any direction involved in that, right?
Yes, yes, boy.
कोई नहीं भाई. कुछ और घुमा रहे थे भाई, कुछ और पहना रहे थे तुम तो. अच्छा जी, राइट, ग्रेविटी। ब्रो, इमान हम वो नहीं लिखते यार। एक मिनट ना, इसकी एग्जामिनर रिपोर्ट चेक कर लेते हैं। Look, majority of the candidate score mark for their explanation of kinetic energy. Few correctly explain the gravitational energy. Lack of the precision generally include using a body instead of mass. Okay, a better word is mass, and omitting the need for the gravitational field. Okay, so you have to write the gravitational field. Getting? Imad, getting? So instead of just writing gravity, you have to say the gravitational field, right? Because gravity is like inside, or gravity is what create the gravitational field around, and if you place any mass in it, so the gravitational field causes the mass to experiences the force. Okay. Should be encouraged not to merely give the equation within when an explanation is required. Okay, fine. So they won't accept the explanation, the equation as well. Okay, fine. So 1/2. Okay, clear हो गया बात, clear है? ये वाला तुम लोग को भी आई होप सो क्लियर होना चाहिए.
Clear as well.
So perfect. So 1/2 into point four into 30 का स्क्वायर कितना आ रहा है भाई, को निकाला है?
Yes, 180 आ रहा है.
180. Good. आ जाओ भाई. Maximum height reached.
Maximum height, age of the ball. Okay,
Any
so
idea?
they've given us initial velocity. So we'll use the equation of motion, right? So S is equals to
अच्छा, by the
V.
way, by the way, by the way, if I say don't use the equation of motion, oh, इन्होंने इन्होंने कह रखा है कि their resistance is negligible, so it is a hint
यहाँ
that you
पर
can
एम जी
use.
एच इज इक्वल्स टू हाफ एम वी स्क्वायर कर सकते हैं?
नहीं, यही तो पकड़ना था.
नहीं कर सकते.
थोड़ा सा चेंज होगा, ये कर सकते हैं बट थोड़ा सा चेंज होगा. और वो चेंज क्या होगा? बिकॉज मुझे बताओ, क्या मैक्सिमम हाइट पे there will only be the gravitational potential energy? Will the
नो
ball
दे विल
stop
बी
moving?
बोथ.
Good. Basically, you have to consider the horizontal component of the velocity, and that will be the velocity at the top, okay? Because vertical component goes to zero, right? So horizontal velocity
यस.
will still be the same and acting at 90 degrees to the horizontal, right? और वो जो होगा, नहीं 90 डिग्री भी नहीं, वो हॉरिजॉन्टल ही होगा. सही. और उसको आप एम वी स्क्वायर लगाओगे, यानी आप यहाँ पे कहोगे हाफ एम वी स्क्वायर या एम यू स्क्वायर कह दो, राइट? एंड यहाँ पे आप कहोगे कि हाफ एम v square plus mgh, right? So you can find out the v by just doing cos theta. Okay. And जो initial है वो आपको पता है, आप उससे भी कर सकते हो, बट खैर हम ऐसे कर लेते हैं. So initial speed is we have the initial speed is 30.
30
ओए, sin theta भी तो बोल. Sin 45,
sin
right?
theta 45.
Okay, and the final speed is how much?
45 30 cos 45.
Wait, come on. क्या मतलब बे? वर्टिकल हाइट अब निकालने लगे, सो वी हैव टू कंसीडर वर्टिकल वेलोसिटी ना. व्हाई आर यू टेकिंग द हॉरिजॉन्टल वेलोसिटी इनटू अकाउंट? समझता है कि नहीं समझता है?
So why are we using the S is equals to VT minus half AT square?
व्हाई आर वी आर नॉट यूजिंग. अभी पहले तो क्वांटिटी तो
Because
लिस्ट लिस्ट आउट करने दो. देखो इनिशियल स्पीड
अच्छा
तो आपको
ओके.
देखो, समझ ही नहीं आ रहा, ऊपर से आ रहा है तुम्हारे. भाई देखो, टू फाइंड द हाइट वी हैव टू कंसीडर द वर्टिकल मोशन, राइट?
ओके.
वर्टिकल मोशन. सही हो गया. पहली चीज हो गई. सो वर्टिकल मोशन के लिए यू शुड हैव द इनिशियल वर्टिकल वेलोसिटी व्हिच इज 30 sine 45. Okay. And we should have the final vertical velocity, and final vertical velocity would be at the maximum height, which will be zero, or which should be zero, right? And since the object is moving up, so it should have the acceleration or deceleration of 9.81. Okay. And we can use s, we can find s. Okay. Getting समझता है?
जी समझता है.
Okay bhai. So 2as equals v square minus u square. So 30 sine 45 whole square with a negative sign divided by minus 2 into 9.81, right?
3 into sin 45 square over 2 into 9.81. You get
Is
22.86.
20.
sir, why is the acceleration negative?
ब्रो ऊपर जा रहा है.
Oh wait,
हाँ बोलो बोलो।
You get 30 sine 45 square over to 9.81. A second. You get
So
22.9.
22.923 मतलब, okay fine. Yes Imad.
So, can you go up for a minute?
हाँ हाँ.
Okay, say question. So, like, why can't you use 2.16 also? Just
टू
use like
पॉइंट
VT minus half 80 square.
2.16 क्या भाई?
At that time where it reaches the maximum height.
अच्छा okay, you can use that as well.
So,
Okay, वो आगे भी कहीं ना कहीं काम आ रहा होगा. देखो, air resistance is negligible so that we can use both of the ways, okay? But if the air resistance may be significant or would be significant, then we are not allowed to use this calculation anymore, right? हमें फिर
so
kind of
whenever we're
time.
doing maximum height, we always take the vertical velocity. We don't take 30, we take vertical velocity, right?
Obviously, yes. Projectile motion के अंदर the horizontal component of the motion and the vertical component of the motion को आपको अलग-अलग treat करना पड़ेगा, right? You can't treat both of the motion simultaneously or together, right? You will end up getting the incorrect results, okay?
Yeah, just 23.
Um, Let me see.
Yeah.
22.88, 22.9, yeah. Okay, clear? इमाद आप क्या पूछ रहे हो?
nothing.
Nothing? Okay. So now they're saying gravitational, okay. What about the gravitational potential energy, bhai? Just do mgh. So 0.4 into 9.81 into how much? H is 23. कितना आता है?
90.252.
90.252. Okay. So 90 is just 90. Okay. And then they're saying determine the maximum kinetic energy of the ball. Okay. What you do? Okay, bhai. So for the maximum kinetic energy, आपको यहाँ पे पता है कि at this point the total kinetic energy was 18. Don't use that. Don't use the cos theta वाला concept, right? Bro, वो एक नंबर दे रहा है. They're only giving you 1 mark, okay? So you know that the kinetic energy over at this point, at the starting point, will be the total energy, and the total energy remain conserved. So when you're talking about this point, so the summation of kinetic and potential combinedly give up give the value equivalent to this energy, right? So you can equate, और आप वहां से सब्जेक्ट बना के सॉल्व कर सकते हो, right? So आप ये कह सकते हो कि भाई kinetic energy at the starting point, yeah, initially should be equal to the kinetic energy at the max height, plus the gravitational potential energy, right? So initial kinetic energy was 180. I think this is what we calculated, yes. And the kinetic energy at the height h is unknown, plus the potential energy is 90, okay? So you can just subtract the value to get the answer. So वो 90 बन जाएगा आपके पास. Okay. And okay. Now explain why the kinetic energy of the ball at the maximum height is not zero, because of the horizontal component of the velocity, right? As a horizontal,
Sir, so if we use the cos 45, we don't get the correct answer.
you will get the correct answer, but working would be very long or very complex maybe. ये
Okay.
चलो, अगर आप बल्कि नहीं ना, वो अगर आप ये कह रहे हो, यानी आप डायरेक्ट यूज कर रहे हो, काइनेटिक एनर्जी इक्वल्स टू half into 0.4 into 30 and cos 45, right? And you are squaring them.
Where?
कर लो, वैसे ही आ जाएगा,
There
90
you
आ
go.
रहा होगा.
90.
यप.
Okay.
सो दोनों चीज़ें सेम है. इसमें इस क्वेश्चन में बाय द वे इन्होंने कुछ इनफ इन्फॉर्मेशन दी हुई है कि जो कि आपको जरूर टाइम का कोई काम ही नहीं हुआ अभी तक. सही है, या रिक्वायरमेंट ही नहीं हुई. सही है. एज अ हॉरिजॉन्टल कंपोनेंट ऑफ द वेलोसिटी इज नॉट जीरो, ओके. सो के ई will also not 0. Perfect. Chalo. Done. Okay. Let's move on to, okay. क्या नाम था यार इसका? Rayan, please read the question.
Define Young modulus.
Mm-hmm. It is a
Stress over strain.
eh,
Ratio of stress over
uh,
strain.
always write the word ratio, okay? Ratio of stress over strain.
Sir, if you write the formula,
They're saying define, okay? So in definition, they won't accept the formula. Like, it is acceptable at your O level, but they won't accept it right here. Let me show you the marking. The examiner, the vast majority of the candidate give the correct answer. Okay, they're not mentioning anything, but okay, okay. By the way, if you're writing the formula, then the rule to write the formula is you have to write everything in the full form. Okay, you are not allowed to write stress over strain like that. Okay, if you're writing the formula, then just do Young modulus instead of E. So Young modulus equals to stress and then the fraction sign over strain. Okay, then it is acceptable. Okay, clear?
Okay.
yes.
Perfect. चलो आगे आ जाओ भाई रेहान.
Two wires P and Q of the same material and original length L0 are fixed so that they hang vertically as shown as figure 4.1. The diameter of P and P is D and the diameter of Q is 2D. The same force F is applied to the lower end of each wire. Show your working and determine the ratio stress in P over stress in Q.
क्या कर सकते हो? अच्छा, by the way, stress has a formula, F over
Area.
area. So yeah, we can write the area as pi d square over 4. Can we? Yes.
Yes.
So, by the way, pi over 4 and f, they all are constant. Okay, three constants are here: f, pi, and 4. So you can ignore all of the constants. So I can say that stress of the wire p times it by its diameter, okay, squared, okay, is equals to the stress in the wire q and times it by its diameter dq squared, right? Can we say that? Okay, but please mention the formula, okay, in the question as well. Like, don't write the this expression directly. Just write stress equals to force over area, right? And then go on and connect the two things. Okay, connect the two scenarios. Okay, now we want the stress of P over the stress of Q, and that would be equal to the diameter of the Q squared divided by the diameter of the P squared, right? And the diameter of the Q and the diameter of P is, okay, so 2 square over 1 square. Okay, so that would be just 4. Okay, is that clear, guys? Yes.
Mhm. Yes.
Okay, and they're saying strain in P over strain in Q. Yes, any idea? We can by the way relate the strain with the help of Young modulus. Okay, they've mentioned that the same material mean you're going to have the same Young modulus. So E equals stress over strain. Okay, so we can say that E1 over sorry, stress 1 over strain 1, or strain in the P, equals to stress in Q over strain in Q. Okay, now so we know the ratio of stress in P over stress in Q, and that is 4. That is 4. And this will give me the strain in P over the strain in Q, which will also be 4 then. Okay. So
But for the one above this, we have
mhm,
to write ratio as 4:1, right?
you can write just 4. You can also write 4 ratio 1, or yep, that's it. Okay, let me show you. Acha, look, by the way, they're first writing the formula, okay, and then they're showing you the substitution, or they're like either to write this formula or to write this formula or to write this formula first, okay? Don't skip the formula, then go on and relate, and after that you can write 4. 4 is the acceptable answer. If you write 4:1, then it is also acceptable, okay? And let's just take you to the examiner's report. Okay. So examiner says majority of the candidate found, okay. Part B, where we find out the ratio of the stress. So the large number of the candidates were successful in completing this calculation. There were a significant number of candidates who were unable to solve the fractions obtained. There was also some confusion when calculating the area using the diameter instead of the radius, or not squaring the radius or diameter. Okay. Majority of the candidates found this part very difficult. Very few realized that as wire were made from the same material, the value of the Young modulus would be the same. Candidates should be encouraged to think the Young modulus as a property of the material itself rather than being the property of the sample. Okay. Like if you have the two sample, okay, of the material, two sample of wire made up of the same material, so they won't have the different Young modulus due to the fact that they both are the different sample from the same material. Okay, this is what they're trying to explain, right? So if you have the two sample of anything made up of the same material, so they will always going to have the same Young modulus. Okay. Okay, fine, fine, fine. So done. Challenge. Let's move on. That's it. Okay. Anybody consider weak? Anybody is weak in the circuitry or consider herself weak in the circuitry? Yes. Nobody? If nobody, then Rayan, you have to continue.
A battery is connected in series with the resistor X and Y as shown in figure 6.1. The resistance of X is constant. The resistance of Y is 6 ohms. The battery has electromotive force 24 volts and zero internal resistance. A variable resistor of R is connected in parallel with X. The current I from the battery is changed varying R from 5 ohms to 20 ohm. The variation with R of I is shown in 6.2.
Okay. So current और radius का graph आपको दिया हुआ है. Can you tell me, by the way, can you tell me the gradient of the graph? Give you which quantity?
Volts.
Come on. Volts? Voltage?
Yes, sir.
No. Gradient is basically the y-axis divided by x-axis, right? So I over R. So I over R won't give you the voltage.
The
To find
potential
the
difference.
potential. Come on, how? Volts and potential difference are the same thing. Like in term of the calculation, in term of the formula.
So then V equals IR is
No, the current with
The
respect to
power?
gradient won't give you the power because V over R is what gave you the power, or actually V
so
square
it won't
over R.
give anything.
Yes, very good,
So I
very good.
square.
Nothing, nothing bro, कुछ भी नहीं देगा. So gradient won't give you anything, but the area does. Okay, and the area will give you the voltage. Okay, it can either be potential difference or EMF or whatever, right? But over here it should be potential difference across the internal resistance. Fine. So okay, क्या नाम है आगे आ जाओ भाई रीड कर लो रेयान.
Explain why the potential difference between points A and C is 24 volts for all values of R.
24 A and C. Okay, yes, because the battery has no internal resistance and A and C are directly connected with the terminal of the battery, right? So they will going to receive the terminal potential difference, which is 24. Getting?
Yes, sir.
Okay, so we can say that the battery has no internal resistance and the AC is connected with or connected across the terminal of the battery. Right? Okay, let's move on.
Use figure 6.2 to state and explain the variation of PD across resistor Y as R is increased.
hmm So if you just see the area under the graph, so maybe the area under the small portion decreases as you move on, or you can use any other concept rather than using this one. Rather than using the area, you can use the concept of the current. So basically, as you de as you increase the resistance, the current decreases. Okay, and if the current is decreasing across R, which mean it has the greater resistance, and in parallel when you have the greater resistance you will have the overall smaller resistance overall. So when you have the smaller resistance finally, so you will end up receiving a small proportion of the voltage. Getting? Is that clear, Irfan?
Yes,
Okay, so
Yeah,
अब यार दोनों के एक ही
that's
नाम है.
because it's directly proportional, right?
No, you cannot say that directly. Like, look,
No,
so
V and R are directly proportional. So if you have smaller resistance, you'll get smaller voltage, right?
look, V and R. But over here, it won't work. Okay, it only work if you have the pure circuit. If you have like pure series or pure parallel, then you can make this sort of judgment. But otherwise, if you have like the combination of the circuit or the combination of the resistance, then like if you are increasing this resistance, right? We are increasing the resistance, but the potential difference across it decreases, right? So this is the reverse. The reverse is going on. Clear? So
Yeah.
increasing the value of R, okay, will give the lesser overall resistance at AC, AC है? Yeah, at AB. Okay, so at AB, so lesser potential difference, potential difference. So basically, you are increasing the resistance, but the resistance is basically connected in the parallel circuit, right? So increasing the resistance in parallel circuit will reduce the overall resistance, right? So that is why you will have the lesser value, right? Okay. Okay, bhai. So fine. Let me just check the examiner report and then or marking key first, and then we'll move on. The voltage loss. Okay, okay, fine. Okay, fine. The current I decreases as R increases PD across. Okay, they're saying as you increase. Okay, I didn't connect it with the figure, so that's why I may lose 1 mark. And let me just also see the examiner report. So signal current decreases circuit potential difference. अच्छा जी, एक minute. Part B, we are doing part A. We are doing part B. Okay. So part B is okay. This is a part B. A significant number of candidates understood that if the current decreases in the circuit, the potential difference across Y must decrease. Many candidates did not use a graph that show the current decreasing with the increase. Okay, and I am the one in them. Okay, there were many misinterpretation of the circuit, which often came as a result of not reading the circuit or text carefully. The effect of R increasing was used in the equation V equals to IR to suggest that the potential difference would increase. The fact that there was if okay, fine. I should also have to include that the graph is showing me the current, the increase in the decrease in the current. Okay. Give the okay, fine. Let's move on. आगे आ जाओ भाई आगे रीड कर लो.
For R 6 ohm, show that the PD between points A and B is 9.6 volts.
Okay. So let me just copy the circuit and ये आ गया, ये आ गया और ये आ गया. सेव. आ जाओ भाई. यहाँ से ले आते हैं इसको यहाँ पे. ओए होए हैवी. क्या बात हो गई यार, ये तो शपाटर हो गया. Okay, okay. So they're saying the R is 6, okay, and AB is 9, okay. What you do? Acha, X is given. Is X given?
No.
So yeah, mic is mute.
Okay, okay, sorry. Okay, so I just read the value of the resistance and corresponding current from the graph. So it shows the 2.4, right? But the graph is from 1.5 to 2.4. Okay. Um, so if the resistance is considered 5, so it should be 1.5, it should be 2.5. Okay. जरा इसको निकालो. 2 मल्टीप्लाई करो जरा. 2.4 इंटू 6. 6 2 12 एंड 6 4 24, तो 14.4 आ जाएगा.
14
14.4 है ना. So
Yes.
14.4 is a voltage at this point. At this point. करंट हमारे पास आ रहा है. There is for R equals to 6, show that the potential difference across AB. जो वोल्टेज हमारे पास R के क्रॉस होने चाहिए वही AB के क्रॉस होने चाहिए. So the current in R is 2.4,
Sir, can't we just do 24 minus 14.4?
but why are you subtracting?
So because it's a parallel
So come on, no.
voltage.
Okay. Look, bro, यहाँ पे over here there will be the same voltage, right? Across both X and R, right? Because of the parallel circuit, right? But the voltage will be shared in between this whole thing and Y, okay? So since we have the current in the R, and that is 2, 2.4, right? And this 2.4 is passing through the resistance of 6 ohm, right? So it will give me the value of the potential drop across this point, okay? This point, right? That include R and that include X. So that will directly give me the potential difference of 14.9 across AB. Then why should I subtract? Although when you subtract, you will get 9.6, but it won't make sense. No? Any idea? Yes? Anyone else? किसी पास अच्छी logic? अच्छा जी, let's see कि इनकी मार्किंग की क्या कह रही है. So current, we read the current as 2.4. Find the potential difference across AB. Why should we subtract? Why they are subtracting? क्या reason है? Okay, इनकी exam report देखते हैं इसमें. The majority of the candidate answered correctly. This the candidate who obtained the current from this graph usually went on complete the calculation. There are many attempt to work backward from the answer, but this was generally unsuccessful. Okay, nice. But यार ये तो गलत है ना यार, ये तो सीधा सीधा क्वेश्चन होना चाहिए. Why are they subtracting? एक मिनट. The resistance of Y is 6. The current I, oh come on. So the current I from the battery is changed by varying R. Okay. So this is not the current passing through the resistor R. This is the current I from the battery is changed by varying R. Okay. So this is basically the current from the battery. Okay. Which is 2.4. Okay. So this is the current from the battery. So can we work out for the total resistance, by the way? Acha, if the okay, okay, fine, fine, fine. So now if we have the current, so the current will then be over here at this point, okay? 2.4 का यहाँ पे भी होगा. So it will give me 14.6, okay, and 14.4, and then आप जब subtract करोगे, so आपके पास आ जाएगा 12 minus 9.6. So 12 minus 14.4 gives you 9.6. Okay, clear हो गया? Yes.
So how is 12 minus 14.4 giving me 9.6?
अब यार 24 है यार, sorry, sorry, sorry.
So why do you subtract again?
Look, the value of 14.4 is basically the voltage across this point. Okay, clear? Because the current in the circuit is 2.4 and not the current in R is 2.4, right? Clear? So what we actually, okay, we have this as 6 and that as 6 as well, right? So I actually so over here ये जो resistance है ये वाला 6 है, Y वाला, okay? So this is the voltage across Y we calculated, okay? And then we go on to find voltage across AB or X, right? तो वो हमने subtract करके निकाला. Clear हो गया?
जी.
Okay, fine. Calculate the resistance of the resistor X, okay? So we have 9.6. We have 9.6 as a voltage, okay? So V equals to IR we can use, okay? So we have 9.6 as a voltage across AB whole, right? मतलब like आप उसको जो है ना ऐसा assume कर सकते हो. Hmm. Come on, copy and paste. सही है. इसको आप ऐसे अज्यूम कर सकते हो कि भैया आपके पास जो है ना, you have ये पूरा आपके पास कुछ भी नहीं है, सही है। और ये पूरा आपके पास जो है ना वो एक पार्ट से कनेक्टेड है, राइट। यहाँ पे अगर आप जो उसमें आपने टेप कर दिया, सही है। एंड ये पूरी चीज़ जो है वो आपके पास एक सर्किट से एक उससे रजिस्टर से कनेक्टेड है, राइट। सही, पहले आपने ये निकाल लिया, सही है। सो आपके पास 9.6 is the voltage across this thing, okay, this whole thing. And then you divide it by the current, which is 2.4, since it is a series combination now. So yeah, this will give you the value of R, which gives you how much? Yes, कोई calculate कर रहा है?
4.
4. Okay, fine. So basically 4 is the combined resistance. So 4 is the combined resistance of X and R1, okay? Which mean now you have to consider the whole thing back again, okay? So अब आपके पास जो है वो यहाँ पे आपके पास this whole thing has a resistance of 4, okay? So आप कर दोगे 1/4 equals to 1/x plus 1/6, okay, because R is 6, okay. So just 1/4 minus 1/6 equals to 1/x, okay. How much? 1/24, 0.2. नहीं, 6 4 10 2 over 1/12.
1/12.
हाँ जी, कितनी आ रही? अब एग्जैक्ट एग्जैक्ट बताओ भाई, उतना तो मैंने भी जज कर लिया। 1/12 is how much? 1/12 is 0.0833. Okay, you are not allowed to give in the fraction form, okay? So basically 0.833.
No, it's 12 because
You
you
have
have
to
to bring it
reciprocate it?
up, right?
Yes, yes, yes.
So
Okay,
it'll be
fine.
12. Yeah.
Fine. Fine, fine, fine. 1/12. And that will be just for, okay, fine. So calculate the power provided by the battery. Okay. So to find the power, you should have the current and the voltage, right? So power is equals to V times I.
So 24 square over वो
ओए,
नहीं करेंगे 24 square over the total resistance.
कर सकते हो बट ख्वारी क्यों करो टोटल रेजिस्टेंस निकालने की? यू डोंट हैव द टोटल रेजिस्टेंस.
Oh,
You
okay.
you have to add the total resistance, but yes, वो फायदा क्या है उसमें? Clear?
But it is possible, right? किस
Yep.
आंसर आ जाए.
Yep. 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 बाय द वे कितना दे रहा है?
57.6.
57.6. Okay. And look, you are allowed this formula, you are allowed to use this formula, that formula, सब कुछ यूज कर सकते हो, okay? चलो, आ जाओ भाई. Yes, Ryan.
Titan explained qualitatively how the power provided by the battery changes as the resistance R is decreased.
Mm, R is increased, okay. So if you are increasing the resistance, what will happen? If you are increasing the resistance, the current in the battery decreases. So if the current decreases, power
Voltage
decreases.
decreases.
Okay. वोल्टेज क्यों डिक्रीज होगा? वोल्टेज ऑफ द बैटरी तो सेम है ना. सो हम ये कह सकते हैं भाई, इंक्रीजिंग आर विल.
तो एक और क्वेश्चन है पी आई स्क्वायर आर नहीं होता.
आई स्क्वायर आर होता है डायरेक्ट. क्या मतलब?
तो हमने ओह नेवर माइंड ओके आई वी है वो.
आई भी किया ना. ओके, इंक्रीजिंग आर विल decrease the current in the battery, okay. So अच्छा, EMF constant है. EMF is constant. Come on. um, EMF is constant, so so power decreases, okay. So power decreases. चलो भाई, हो गया, perfect हो गया. Okay, last question. Yes, last question, okay. um, Imad, please read the question.
A laser is placed in front of a double slit as shown in figure 7.1.
Okay.
The laser emits light of frequency 670 terahertz. Interference fringes are observed on the screen. Explain how the interference fringes are formed.
Hmm. Okay. So basically, a laser light from the laser get refracted from here, okay, and become two light sources of the coherent frequencies, or two light sources of the same constant phase difference, right? And when they start meeting at the screen, they form constructive and destructive interference. So constructive interference, you have to write the condition for constructive interference and condition for destructive interference, right? So
So you
clear?
don't have to say the overlap.
What? Yes. So look. So first, light from the laser um, diffracted at slit. Okay, the two lights have the constant phase difference or coherency phase difference. Okay, they overlap. अच्छा, ओवरलैप के बजाय हम इंटरफेयर अगर कह दें या सुपर इम्पोज कह दें.
Constructive interference, right?
Hmm, wait. एक- if they superimpose, right? अच्छा जी. If they superimpose or meet at the screen, okay, screen, okay. You don't have to write constructive interference because there will be the destructive as well, right? They superimpose at the screen, okay. Um, अच्छा जी, forming um bright and dark spot and dark spot, okay. अच्छा जी. So bright spot would be due to the phase difference of n times 360 and the path difference of n lambda, and जो आपके पास dark spot होगा, dark spot would be due to due to um, path difference of 2n minus 1 lambda minus 1 times 180, okay, due to the phase difference of this much, and path difference of n plus 1 over 2 lambda, okay. So this is what you have to mention, okay. And
So we can't write about constructive and deconstructive interference
wait,
here, right?
destructive. Actually, these are like the bright spot and the dark spot shows the constructive and the destructive interference, right? But they're saying
Yes.
how the interference formed, right? Like you have to tell them how, right? And to answer how, so you have to write the phase differences and part differences value, right? So that will be acceptable, okay? Or that is required. So just write, I just read this one. The answers are often lack in the detail required at this level. Ray or light were the term often used. Okay, I use this term. Look, used instead of wave, okay, so we have to use a wave instead of light or rays, okay, so that should be corrected, okay. Candidates should be encouraged to use the correct term when asked for the explanation. They needed to for the wave to be coherent after passing through the slit was seldomly described by the candidate. Okay, मैंने किया है. The description of the crust on the crust for the maximum is not sufficient at this level. A description is involved path or phase differences between the wave that reaches a screen should be encouraged. Okay, there were a significant number of candidates who confused path and the phase differences. Repeating the word in the question without any further explanation will not gain any credit and should be discouraged. Okay, so we rather have to say light, we rather have to say the wave. Okay, wave. Okay, fine.